The last video argued that the derivative of the profit function with respect to labor, or any other input, if that's the one you're changing, when it's equal to 0, that's going to be the point that maximizes profit. And we talked that this thing is called the first order condition. And the basic argument is also kind of easy to see graphically. If we have profit on the vertical axis, labor on the horizontal, if this derivative is positive, that means that if you increase labor, you're going to also increase profit, and so you're going to kind of go in this direction. All right? And as long as that's the case, you should just keep increasing labor, right? Because it'll increase your profit. But eventually you get to some point where a further increase in labor no longer leads to an increase in profit, okay? And now, if the first order condition is turned negative, we're in a situation where if you increase labor some more, profit actually starts to fall, okay? So what does that look like? Something like this, okay? So now as we're increasing labor, profit keeps dropping, okay? And you can see that there's only one point here where the first order condition, so the derivative, the slope of this function, is only equal to 0 here. It's only totally flat there. And you can see that this is the profit maximizing point. That's the profit maximizing labor supply, or labor demand, how much labor you want, when the derivative with respect to labor is equal to 0. Now, that's how things are normally going to be, and we'll explain why in a minute. But first, we need to rule out a kind of alternative case that would be bad for us, okay? Suppose instead of what I just drew, we have this. Here's 0 profit. Here's labor, and this is actually down here negative profit, so losing money. What if, as you increase profit, the first order condition is negative, and so you start off like this, and this could correspond to a situation where the first couple workers you hire can't produce very much. Maybe you need a minimum of like 6 workers before you can produce anything, and so the first 5, they're not producing anything, but you still have to pay their wage bill. It's a possibility. So in this case, at the outset, the more workers you hire, the lower your profit goes. And then we'll say you hit a turning point where now your workers start generating stuff and they can kind of pull you out, okay? Now this stuff starts to rise. So this is a perfectly valid way to draw this. Like, we could draw it this way. And if we look at the point where the first order condition is equal to 0, it's at the profit minimizing labor demand. And so this is a bit of a challenge for us. This is saying that we know that the amount of profit is maximized when the derivative is equal to 0, as long as we're in this situation over here, okay? If our profit function instead looks like this, then following that rule will actually give you like the worst possible outcome. So it's pretty important to get that right. And we have an assumption that we talked about earlier that's going to guarantee that that we're always in this case where we can, we're always over here, where setting the first order condition equal to 0 maximizes profit. And the way we're going to do that is we're going to develop a new condition called the second order condition. So let's graph these guys, derivatives, and sort of we can see that there's an important difference between them, okay? So I'm going to erase this stuff here. And whatever. All right. Here. Okay, that's fixed. So instead of graphing profit here, let's graph the derivative of profit. Let's graph the first order condition for each of these figures. So in this one, we talked about how at the beginning, if you increase labor, you increase profit. That means that the first order condition is positive, but you can see that it's kind of dropping. And by the time it gets to here, we're at the point where the first order condition is equal to 0. So we need that point there. And before that, we're positive, and then after that, we're negative. So we look sort of like this if we graph this guy. Okay? Notice the slope of the first order condition, which is itself a slope, I know it's confusing, is negative. Okay? On this side over here, we know that this point here is where the first order condition is equal to 0. But before that, it's negative. As we increase labor, the profit is falling. And so we get something that looks sort of like this, right? It's increasing as we go through. And the important point is that the slope in this situation is positive. And the second order condition is a way of basically using that to check if you're in this good situation or the other kind of bad one, okay, where you can't use your simple rule. So we need to what we need is, let me just say this way. For the first order condition equal to 0 to tell us the profit max, we need the derivative of the first order condition to be negative. Remember the first order condition is the first derivative of the profit function. So if we take the derivative of that, it's the second derivative. So this is the condition, that this thing is less than 0. Now let's go back to our actual profit equation and see if this is likely to occur. Okay. So, and this is called a second order condition. Okay. Profit is equal to P times F, K of L minus our costs. Let's take the derivative with respect to L. We get P times this minus W. This is our first order condition. Now we're going to take the derivative a second time. And we have to take the derivative of this, so this becomes a second derivative. And the derivative over here is 0. There's no labor around, okay? So if this one is less than 0 and this one is equal to 0, we found our, we can be confident that basically we found the profit maximizing point, okay? Fortunately for us in this course, we've kind of made an assumption that guarantees that this second one is going to hold, okay? We assumed, this is an important assumption for this technical detail, diminishing marginal products. Okay, remember the marginal product of labor or capital is how much extra output you get when you increase your labor or you increase your capital. The diminishing marginal product assumption guarantees that if we take the derivative of the marginal product of labor with respect to labor, it's going to be negative. Okay, as you add more labor, you get less and less extra output. Okay, that was an assumption we kind of had in the background, and this is why we make that. Okay, if this is true, well, where's my cursor here? This guy here is equal to the price times the marginal product of labor. This guy here is equal to the price times the derivative of the marginal product of labor with respect to labor. We've assumed that this second part is negative. Prices are not negative ever, and therefore we can be assured that as long as we have the assumption of diminishing marginal product, this second order sufficient condition is always going to hold. So in practice, if we have diminishing marginal product of labor, you know that the second order sufficient condition, the second order condition is going to hold, and so you can find the profit maximizing point by taking the derivative of the profit function and setting it equal to 0. So one more video and then an example, and I think then it will start to click, hopefully.